So you can highlight what a logarithmic equation is. And then we can go to example 1. So what's going to happen with logarithmic equations? So last class we learned how to solve for x when it's in an exponent. And when x is in an exponent, you can either change the bases to be the same or use logarithms and take the log of both sides. Today we're going to look at what happens when the x is inside a logarithm and how do we solve it. The idea for solving inside of a logarithm is that we're going to want to change it to exponential form. If we can use our definition of a logarithm to change it to an exponential form, we'll be able to solve it. However, the only way that we can use our definition of a logarithm is if we have a single log. So as far as our steps go, what we're going to do is first we're going to use our log laws to write our log as a single logarithm. So we're going to use our log laws to write it as a single logarithm. Then once you've written it as a single logarithm, then you can use your definition of what a logarithm is and write it in exponential form. Once you've changed it to exponential form, it will be easy, and you'll see how to solve for x, because it'll become a question that you've done before and can easily solve for x. The last thing that you have to check for is extraneous roots. Because if you think about what does the graph of a log look like, you can't take the log of a negative number or a 0. Because our graph of our log, any log graph looks like this, right? And its domain, there's an asymptote right there at x equals 0. And you can only take logs of positive numbers. So if you get an answer for x, and that x value that you get an answer for happens to be a negative number, you're going to find out that that's an extraneous root. And we're going to see some examples of that. So for this first one, we got log 3 9x plus log 3x equals 4. Can you use your definition to change this to exponential form? No, because it's not a single log yet. Do we have log laws that we could write this as a single logarithm? Yes. What happens when we're adding two logs? Multiply. So we can write this as log 3 of 9x times x will be 9x squared equals 4. So there's step 1. We used our log laws. We wrote it as a single log. Once you have it as a single log, your definition of a logarithm says you can write this in exponential form. The base is 3. The exponent, 4, is equal to the answer, 9x squared. 3 to the 4 happens to be 81 from your powers chart. Divide by 9. And what do we get when we square root this? 3 and negative 3. Because when you square root, you have to remember plus or minus. But once we've got our answers, now we check with our original equation. And all you have to find out is, if I plug in 3, do I ever have a negative inside of a logarithm? So in the first one, you have 9 times 3, that'd be 27. That's okay. In the second one, you'd have 3. That's okay. So this one is fine. But negative 3. Will you ever try to take a log of a negative number if I put in negative 3? What's 9 times negative 3? Negative 27. So right away, you know this is bad. Okay? It's not because the answer is negative, because you can sometimes get an answer negative, that's fine. It's because when you plug it into the logarithm that you take a log of a negative number, and that doesn't fit the domain of a logarithm. So when we plug this in, right away we're taking the log of a negative number. That's not okay, so we get an extraneous answer. You will always do this when you're solving log questions. You will try to write it as a single log. Once you've written it as a single log, you'll change it to exponential form and then solve. We'll run into some questions where there might be some shortcuts along the way, and that's fine, but this will always work. Questions you can do so far are 3, 4, and 9, and then we'll go to example 2.